Number one, when it's on a solid bar model like that, what operation is that? When two things are sitting next to each other. Yeah. So what expression would we write? Perfect. Okay. Here, same thing. It's on one bar, but I've got the same thing over and over and over. What operation is that? The multiplication, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Number 3. We're supposed to write it and then draw a model. 12 points fewer than the Astros. What do we not know? We don't know the Astros, right? So that could be our variable. And if we're going to do 12 points fewer, subtracting 12, okay? And then what would our model look like?
We do one bar of 8 and then below it.
Okay, so I could put A and I could do this, right? Because that means that it's been taken off. Or I could do with the 12 underneath it as part of it, right? Or I could do algebra tiles, right? A, and then I need 12 shaded. These are both a model, okay? All right. Quotient of a number n and 6. What does quotient mean? When we divide, that's right. So we're going to do n divided by 6, or n over 6, okay? What would a model look like? Good. I can cut it like that, and the whole thing represents n, but if all I want is 1/6 of it, then how do I show that? Yeah, I just need to shade 1. Okay? And then the same thing, you can take an algebra tile and then cut it as well, just like that. Is everybody good? Okay. Today, we're going to just talk a little bit more about combining like terms like we did yesterday. And then we're going to do the test review towards the end of class. Okay? When addition and subtraction signs separate an algebraic expression into parts, each part is called a term. Remember we talked about that yesterday? A term. And that's why we said like terms. The numerical factor of a term that contains a variable is called the coefficient. What does that mean? Like in 2x, 2 is the coefficient because it's the number part of the term that has the variable. It's the coefficient. A term without a variable is called constant. Remember yesterday we said that's just like a number? Okay? Like terms are terms that contain the same variables, such as x, 2x, 3x, or those all numbers, okay? It's all good. So if you look at this example, 3x plus 7 plus x, there are 3 terms in that example, okay? 2 of them are like terms because they're both an x. And then what is 7? It's the constant. The constant is 7. Okay, so let's take a look over here at this diagram and see if we can label it. Okay, so this word is pointing to all 3 things. So what would that be? Terms. This box is just pointing to that number. What's that? Constant. Guys, if I'm right, you're right. Okay. This box is just pointing to the 4 and the 2 that are attached to the variable. Coefficient. It's just like this one, okay? Okay, so when it comes to simplifying expressions, we've kind of already, like I said, been doing this. Like on the first one, x plus x would be 2x. Can't go any further. Negative 4 times 6x would be negative 24x, okay? It's It says two expressions are equivalent when the expressions have the same value, no matter what the value is substituted for x, okay? So what we mean is, if I was to plug in, let's just say a 2 right there. What is 6 times 2? 12. And what's 12 times negative 4?
Negative 48.
And if I were to plug in a 2 right here, negative 24 times 2 would be what? Negative 48. So you guys, that's what they're saying, that they're equivalent expressions, and so that when you plug in the variable, you're going to get the same values, no matter which side you do it on. When you simplify it, if, as long as both sides are equal, okay? Yes. Okay, so let's take a look at this one, okay? 3 times x times 11. Well, I can either combine them the way they are, like 3 times x would be what? 3x. And then times 11 would be what? 33x. Or I could have used, like, the associative property to rewrite this as 3 times 11 times x. What's 3 times 11? 33. And then what's 33 times x? 33x. Do you see, guys, that those are equivalent to each other? Yeah. And then it wouldn't have mattered what number I plug in for x, it would have always worked. Okay? Okay, we're going to skip around, like I said, today a little bit because some of this is redundant. We've already talked about it. Let's move down here where we now have 2 variables. 2 variables. Okay? If I have x plus y, what would that all simplify down to?
2x plus y.
Yeah, 2x plus y. Because those are like terms, right? What about over here with this 4 sitting out there? What does that mean? Distributive property. So 4 times 2x, 8x, and 4 times y, 4y. Can I go any further? Why not?
You don't know the.
Because they're x's and y's, 2 different terms, can't go any further. Okay? Questions? All right, let's look at the next one. Letter A, I've got parentheses. Do I need them? How do you know? Because it's just adding. There's no sign in front of here, so it's understood to be positive. So that means I can just take them out. Now what? Like terms. I've got a y. Do I have any more y's? Plus 22y. So what's 14 plus 22? 36y. And then my other term is just that. What is it? Plus x. That's it. Okay? How about the next one? 3x plus 2x would be 5x plus 9y. Can I do anything further? How about the next one? What does this mean? Distributive. So 7 times 3x would be 21x, and 7 times y, 7y. And I can't go any further. Guys, does anybody have any questions so far? Okay. Let's go on to the back. Right? Now, the good news is that all the stuff on the front, all that's on the test. This piece right here is not on your test, and actually, I want you to put a little note up there that this piece is extra, meaning it is important for you to know in math, and I'm challenging you right now, this specific piece is not on your test. Do you remember last week when we were practicing the distributive property, and I said to you, if you understand all this distributive property stuff, then there's this challenge page that says all of these have already had the distributive property applied. I want you to go backwards and see if you can figure out what it was. Do you remember that? Yeah. Well, that's what this is. So I'm going to show you how to do that, okay? It's called factoring. To find equivalent expressions, we can also factor an expression. It's just the reverse process of the distributive property, okay? So when you look at 27x plus 18y. What you want to do is find the greatest common factor of those terms and pull it out. So that means, think about 18 and 27. Pretend that they're like fractions, like 18 and 27, 18 over 27, right? And you're trying to simplify them down. What is the greatest common factor? What does that mean? The number that they're what? Both divisible by, right? What are they both divisible by? 9. Anything else? And 3. But which one of those is the greatest common factor? 9, right? Because it's the biggest one. So in this case, the GCF would be 9. So we're going to put 9 out here. 9 is what we'll multiply everything by, okay? So now you have to say to yourself, how do we get from 9 to 27x? Times 3x. How do we get from 9 to 18y? 2y. That's it. Okay? But then I want us just to come over here on the side, or you can go on the top, you've got space on the top, and rewrite it and check it and see if it works. 9 times 3x, 27x. 9 times 2y, 18y, and so it works. How many of you already kind of figured that out on that challenge? Yeah. Okay, let's look at 36 and 60. What would be their greatest common factor? Oh, I heard 6. 12. It would be 12, okay? 12 to 36x would be what? 3x. 12 to 60? 5. Okay, again, let's come down here and just check it. 12 times 3x would be 36x. 12 to 5, 60. So we know we got it right. Okay? You guys ready to try this on your own? Okay, go ahead and do this next row right here on your own. Okay, so A. Did you guys get 4 groups of 3x plus 2y?
Yes.
Okay, B, 7 groups of 5x plus 4y.
Yes.
Okay, how about C? 2 groups of 8x plus 20.
No.
Say, what do you mean?
I just made 4 and 1.
Oh, so I did factor out of 2. 2 times 8 is 16x, 2 times 20 is 40y, but what's wrong with it? That's right. This 2 is not the greatest common factor, so while I did factor it, I didn't factor it all the way down. The greatest common factor would be what? 8. Yeah. I just wanted you guys to see that, okay? Okay, we're going to skip this middle section for now, and then we're going to come all the way down here to the bottom to number 15. Let's look at number 15, okay? So now number 15 looks kind of long, looks a little scary, but really, is it? Okay, let's look at this number 15. What do we need to do first? Parentheses. What's 5 times x? 5x. What's 5 times 3? 15. Bring everything else down. Everything else that was already there, just bring it down. Okay, now we're just where we were yesterday, combining like terms. So let's box. I've got 7x, 5x, plus 4x, and a minus x. Okay, so 7x plus 5x would be what? 12x. 12x plus 4x would be what? 16x minus x. I thought it was 15x, right? Yeah. And now we've got a plus 15 and a minus 2. Plus 13. Yeah. I want to show us another way to do this one, and that's going to help. A minute ago, when we were adding and we were like, I think we lost track of our problem. If you will just make yourself a little T-chart, not x and y, but x and numbers. Okay, do this with me. In the x column, let's write down all of our x terms. We had 7x, 5x, 4x, and negative x. In the numbers, we only have 15 and minus 2. Now, Does that help you to visually see combining them a little bit easier? Let's see, 7 plus 5 was 12 plus 4, 16 minus 1, 15x, and then 15 minus 2 plus 13. Okay, it's just another way to do it. Guys, we don't really care which way you go, okay? All right, now let me tell you what I'd like for you to do, okay? To these problems, right? Go ahead and check your answers. What can I go over? 14. I agree. Whenever I first read 14, I was like, what? And you have to read it again. So, it says that Gabriel's X years old, or Gabrielle, sorry, is X years old. So they just put X on here. The sister Felicia is 6 years older. So that's where we got Felicia was plus 6, X plus 6, okay? Then the mother is twice as old as Felicia. So you would take Felicia and multiply that times 2 to get the mother. Then it says the aunt, Tanya, is X years older than the mother. So here's the mother. So you would take all of that and then add 6 to get to Tanya. Now they want you to simplify this expression. Distribute that out and then combine like terms. But without writing down each person, I think this would have been very, very difficult, okay? What else?
It's still it's the aunt is older than it's X year older than their mother, so that X is equal to their little X.
In this particular problem, yeah, I would think that would be hard to believe that this would apply all the time. Meaning like if Gabrielle is 7, then you would figure out, if you plug in 7, is that true? Yeah. Okay? Anything else on this page, guys? What about 16? Did we get 16?
Yeah.
Oh, good. That's the one I was worried about. But y'all were okay?
Yeah.
Okay.